So if you have an equation with several variables in it, you might be asked to solve for a specific variable, or what's sometimes called a variable of interest. In other words, you isolate or get that particular variable all by itself, and you express it in terms of all the other variables or all the other expressions in that particular equation. Let's see what I mean. Now here's the equation. It has to do with gases. You'll see it in one of your science courses. If not this year, then maybe in the next year or two. It has to do with pressures, volumes, temperatures, to determine basically how a gas expands or contracts based on some of these topics or some of these particular variables. So the equation itself is not so important, or the meaning of it, as to what variables in it. Okay, so you can see we have a P, we have a V, and we have an N, an R, and a T. And sometimes you'll see some of these capitalized, sometimes not, depending on which science book or which science course you're taking. It just doesn't matter. The whole thing is PV equals nRT. So if we wanted to solve for P, pressure, we need to get pressure by itself. So we need to get that P by itself on the left side, and the only thing with it is the V. So if we divide both sides by V, by volume, V divided by V is 1, so that just kind of goes away, and you're left with P is equal to nRT over V. And that's how you solve for that particular variable of interest. Now, let's look at it again. PV equals nRT. What if we wanted to solve for R, or temperature, say T, right here? Okay, so what do we need to do? We need to get T by itself, so we need to get rid of the N and the R. So if you divide both sides by NR, then the N divided by N is 1, R divided by R is 1, so you get 1T on the right, and on the left you get PV over NR. There you solve for temperature. Here you solve for pressure. Let's just do one more. What if you wanted to solve for N? So PV equals nRT. Solve for N. So you want to get rid of the R and the T on the right side. So you divide by RT. Divide by RT. R divided by R is 1. T divided by T is 1. So you're left with 1N on the right. And it's equal to PV or RT. And that's how you solve for a variable of interest in a problem like this, where they're all multiplied by each other. Let's look at another example. Okay, this is called a slope-intercept form of a linear equation. Y equals mx plus b. And as we go into this course, you'll get into this more, but for right now, we're not too concerned about what all these mean yet. Okay, what if we wanted to solve this particular equation for b? Well, we have an mx attached with that b by a plus sign, so we need to get rid of it. Okay, so you can't divide by mx over here, because if you do, you'll be left with the 1 plus b because of the plus sign. So you have to subtract the mx and subtract mx over here. So you end up with y minus mx is equal to, those will cancel out, so it's 0 plus b, which is just b. So now we've done it. B is equal to y minus mx. What if you wanted to solve for x? Y is equal to mx plus b. First thing you might want to do is subtract the b from both sides. And you get y minus b is equal to mx. Now, you want the x by itself, so now you can divide by m because they're multiplied by each other. Divide this by m. M divided by m is 1, so you get 1x on the right. And you get y minus b over m on the left. And you can't simplify that anymore, so that's solving for this variable of interest, which in this case is an x. Over here, in this case, the variable of interest was a b. Okay, let's look at another much easier example. Okay, force equals mass times acceleration. This is basic physics equation here. Okay, Isaac Newton and all these guys, the pioneers of physics. This is one of the most basic physics formulas. Force equals mass times acceleration. Well, what if you knew the force and knew the mass, you could figure out the acceleration. All you have to do, if you wanted to solve for acceleration, divide both sides by m. M divided by m is 1, so you get 1a on the right, or just a, is force divided by mass. If you wanted to solve for the mass, you divide both sides by acceleration, and you get mass is equal to force divided by acceleration. See, we've solved for the variable of interest, which is mass. We solved for the variable of interest over here, which was acceleration. And the original equation solves for force is equal to mass times acceleration. So that's a fairly easy example. Let's look at a difficult one. Okay, in this case, Einstein's famous equation, E equals mc squared. Energy is equal to mass times the speed of light squared. So, if you know the mass, the speed of light is a constant, so you just multiply mass times the speed of light squared, and that gives you the energy. But what if you didn't know the mass? What if you knew the energy and you wanted to figure out how much mass that was? Okay, so you want to solve for mass. What do? Oops. Divide by speed of light squared. Those cancel on the right side, give you 1m on the right, or just m. The mass is equal to energy times divided by the speed of light squared. Even though the speed of light is a constant, so it's not something you should have to calculate, but just for the sake of this particular exercise, what if you knew the energy and the mass? Could you calculate the speed of light? Sure. Okay, so let me make some room here. We know that Einstein's famous equation, E equals mc squared, and now I'm solving for c. So first I want to divide both sides by m. Okay, those cancel, and I get c squared is equal to energy divided by mass. But I don't want c squared, I want c. So to find c, I have to take the square root of c squared, which means I have to take the square root of that. And the square root of c squared is just c. And now I can't simplify this other than saying that the speed of light is the square root of energy divided by mass. But that's how you do it. So anytime you're looking for a variable of interest, Figure out what that variable is you're looking for, and then just use the properties of equality, whether you're adding, subtracting, multiplying, or dividing, just to get rid of all the other terms so that you get the variable of interest all by itself. And that's how you do that.